Hi, I'm Amy at the Altis store. We're often asked what the difference is between monocrystalline and polycrystalline solar panels, so we thought we'd show you. You can see here I have two solar panels made by the same manufacturer, SolarWorld. This one is monocrystalline and this one is polycrystalline. A couple of things stand out right away with their appearance. This is due to how the solar cells, or the individual squares, are made. The monocrystalline panel is a consistent black or very dark blue color. It's cut into wafers from a conical silicon ingot that's been grown in the lab. To make the ingot, the silicon rocks are melted at 2,500 degrees Fahrenheit, and then a seed crystal is lowered into the melted slush and slowly pulled up while rotating. It's almost like making a hand-dipped candle, but instead of melting wax, you're melting rocks. Because of the round shape, there's a lot of material that's wasted as they cut it into the required square shape. That's why they usually have rounded corners to help minimize the waste. If you look at older solar panels, they actually made them with round cells. Here's a picture I took of an old Arco solar panel from about 30 years ago, and it still works for the record. Polycrystalline cells are made a different way. They load about 1,300 pounds of silicon rocks into a 3-foot by 3-foot quartz mold to create a square shape, and then load it into a 2,500 degree Fahrenheit furnace. It takes about 20 hours to melt and about 3 days to cool down. The polycrystalline panel has a blue mottled look, like a piece of particle board. Looks like it's made up of a bunch of multiple chips of silicon pressed together. But that's actually caused from when the melted silicon cools and hardens. It crystallizes like frost on a window. When it's sawn into the wafers, there's much less wasted material from the square ingot than from the round monocrystalline ingot, and it's a less expensive manufacturing process. Due to the higher cost of manufacturing, monocrystalline panels tend to be a little more expensive than polycrystalline panels. Though efficiencies in manufacturing process are really reducing the cost differences. Okay. So monocrystalline panels look different and cost a little more than polycrystalline. But the big question is it worth worrying about the difference? To help answer that, let's talk about performance differences. Monocrystalline solar panels tend to be more efficient than polycrystalline solar panels. Let's say on average about 17.5% versus 15.5% module efficiency. So they are 2% more efficient. What does that really mean? It means that you can have slightly more power in the same amount of space with monocrystalline than polycrystalline. Let's look at the two panels I have again. They're both the same size, about 38 inches by 66 inches. The monocrystalline panel outputs 270 watts. The polycrystalline puts out 260 watts. If I were to build a system with 20 monocrystalline panels, I get 5,400 watts. To do a similar system with 260 watt polycrystalline panels, I need to use one more panel for 21 panels to get 5,460 watts. That would mean using a little more space, a little bit more racking, and if using microinverters or DC optimizers, more equipment needed. So while the cost of the solar panels may be less for polycrystalline, the overall system cost may be the same when you take the extra equipment into account. One performance difference is how they react to temperature. Monocrystalline panels handle the heat slightly better than polycrystalline. How slight is slight? Comparing the temperature coefficient of the two types shows us that monocrystalline short circuit current drops 0.04% for every degree Kelvin over standard test conditions of 25 degrees Celsius, or 77 degrees Fahrenheit. So if it's 20 degrees hotter on the roof than in the test suite, which is highly likely in the summer, the monocrystalline solar panel can lose 0.06 amps out of a rated 8 amps. For polycrystalline, it loses 0.051%. That equals losing 0.08 amps. So the difference is 2/100ths of an amp. In extreme desert conditions, the difference may be big enough to matter, but for most residential environments, the difference is quite small. Finally, monocrystalline panels tend to behave a little better in less than perfect light conditions. No solar panel, regardless of their type, performs well in the shade, period. But If you have slight shading issues or tend to have hazy skies, monocrystalline panels may perform a little better. However, with the availability of microinverters and DC optimizers maximizing each panel in the solar array, the difference may not be noticeable. Or if you've located your solar array so that there's no shading issues, there's no difference at all. So as you can see, the differences between monocrystalline and polycrystalline panels is not as dramatic as it once was. Advances in technology have made them practically interchangeable. So your choice of which crystalline technology to use may simply come down to color preference or space constraints. I'm Amy at the Alti Store. Check out more of our videos and go to our website at altistore.com, where we're making renewable doable.